This device was invented by Aki Blomstenberg in Sweden in 1977 and was originally referred to as a blower window. In 1979, he traveled to Princeton University to introduce this idea. It was later modified by David Grimsrud to fit a door. In 1988, Tooley and Moyer documented their findings using this device as MAD air, which is an acronym for Mechanical Air Distribution and Interacting Relationships. This can essentially be summed up as observing and studying pressure differentials between conditioned spaces and their neighboring exterior environments. Conditioned spaces can be either a room in a controlled climate, such as a residence, or the ductwork that delivers that conditioned air to the rooms. Pressure differentials can also exist between the conditioned space and the ductwork, thus further exacerbating any differential that exists between the conditioned space and the outdoors.
Untreated outdoor air infiltrates a building when the pressure indoors is less than the pressure outdoors. Conditioned air will exfiltrate from a building when indoor pressure is greater than outdoor pressure. For instance, if a supply duct leaks to the outside of the house, it creates a negative pressure within the house. Supply air lost to the outside causes the return to starve for the air lost, thus depressurizing the house to make up the air lost. Untreated outdoor air will then infiltrate a building when indoor pressure is less than the pressure outside. An excessively negative indoor pressure, as we see here, can cause problems, such as hindering your ability to effortlessly open outward swinging doors, because the negative pressure wants to keep the door sucked into the house. Adversely, return duct leaks that draw air from the outdoors can cause positive pressures within the house. Here we're introducing outdoor air into the return duct. For every CFM that is gained through the return duct, or through a supply or return leak for that matter, a CFM will then exfiltrate through the cracks and holes in the structure, whether it's a window, a door, a hole in the roof. It does that in an attempt to equalize the newly introduced positive pressure. Ideally, the net pressure within a building relative to the outdoors should range from slightly negative to neutral during the cold weather season in order to minimize exfiltration, as demonstrated here. Adversely, the net pressure within a building relative to the outdoors should be slightly positive during the warm weather season to minimize infiltration, as seen there. Any infiltration during the cooling season can raise the dew point within the building's envelope, encouraging microbial growth such as black mold or bacteria. That excess moisture can also accelerate any structural deterioration that occurs from this exposure. A return air duct leak within the confines of the house will then, when introduced, introduce an excessively negative pressure in the basement or crawl space of the house. That negative pressure then wants to equalize, and then it in turn goes positive in the upper levels of the house, thus exfiltrating through the walls there. If you then close off a partition separating the two rooms from one another, then the negative pressure from the one side then gets forced to the return or the supply side of the ductwork and exfiltrates the house. A similar situation occurs when a leak in the supply side of the ductwork is introduced into the confines of the same house. As it's introduced, the pressure in the basement then goes excessively positive. That excessively positive pressure is trying to regain the air that it's losing from the positive pressure to the exterior of the house. It's trying to gain that through other areas of the house, as seen here on the second level. Now, when you close off a partition separating the two upstairs rooms, all of that air that it's trying to replace into the positive basement is now being drawn only from the return half of the body of the house, and it is being expelled through the supply half of the house.
So in a nutshell, return leaks below, Supply leaks suck.